All right, Shashank. So you are today acting as a customer, and I'll try my best to answer any questions you may have. Don't throw any curveballs like a typical customer, but yeah, let's see how it goes. All right,
Sure, Ashish. Let's get started.
great. So hopefully you attended last session and you had an idea on how this machine learning works, what is artificial intelligence, but still we haven't reached to the part where we talk about generative AI. So do you have any questions or anything which you want me to discuss before I talk about your use cases or your business problems?
How you introduce me to Gen AI, and that's what I'm curious about, and I'm interested to know more from this
Great.
session today.
Makes sense. So yeah, Gen AI is something which we are seeing. So I would call it Gen AI is a fruit of the tree which we call artificial intelligence. So obviously, a fruit is not existing into a silo. It is on a tree. Tree would have a stem. Tree would have branches. Tree would have other parts also. Same thing applies here. So what we saw so far was artificial intelligence, and we talked about machine learning. Now, before I explain you how Gen AI works, I would prefer to explain you about deep learning, because this is also important thing to understand, that how we arrived to Gen AI and what made Gen AI possible. And if you are preparing for exam, like this is a certification track, so expect some question on Gen AI and deep learning all together. So I'll try to explain what deep learning is. Now, if I further go on to the same pyramid type of structure which I showed you, and I talked about that AI is a machine simulating human intelligence. AI subset is machine learning, which is machine's ability to learn without explicitly being programmed. And then a subset of machine learning further comes down, which is machine can process the data that is inspired by the human brain. So how a human thinks, obviously we have one of the best brains in the whole universe as of now, not me specifically, but human as a species. So that's what is also inspiration of how deep learning worked. And I'll demystify a few things as we move forward, that how deep learning works. So AI is the broader term. Within that, we have ML, and within that, we have deep learning. And where Gen AI fits in, we will talk about that also. And people who are into chat, please ask question. Please have any discussion points. Feel free to put them into chat, and we'll try to answer as much as we can. Now, why we need it? First thing comes that okay, you created AI. Why you need then machine learning? Why then you need deep learning also? What you are trying to achieve here? So I'll talk about why we are creating more solution based on artificial intelligence. So see this example here. So here we are talking about that, okay, we are trying to solve complex problem. Simple problem, math problem, we created calculators for that. Computers were also able to do these things. But now we are looking for more complicated problems to solve. Maybe identifying a picture, or maybe identifying a pattern, or identifying some other things within a given environment. So in those kind of cases, our complexity of problem we are solving is increasing. And that's where we have to find better solution to understand those type of things. So uh, then we have hardware based constraint on implementations, and that's what is able we are able to uh, put into picture. Like, let me give me a minute, let me try to draw this thing. So what we are trying to achieve here, that we are trying our best to find out solutions which will allow us to create solution for the problem which are very very complicated, which are not as simple as 1 plus 1 equal 2. So that's why we have to figure out a way of doing these things on a hardware side also. That's what is actually happening. Does it make sense? Give me a minute.
It does.
I got a message from Pawan that says that are we still on YouTube? Could see it off YouTube for 1 minute and then I can't. Let
I
me check
checked it,
with them.
Ashish. I checked it. It was working fine for me.
Okay, it's working fine. Good.
Yep.
Thank you. So, Pawan, if you're hearing, maybe it's just a refresh which is needed, maybe a different browser probably, and hopefully it should be okay. I could see 131 people as of now live. So not everyone would be probably from LinkedIn. So yeah, GK, thanks for confirming. Okay, it's working. Good, good, Pawan. Thanks for confirming. All right. So what we are trying to achieve here is that as the problems are becoming complex, we are trying to create solution around those problems, and that's where your deep learning thing is coming. Now, why you may have a question, why you are calling it deep learning? What is actually happening here? What is deep learning? Why the word deep here? Artificial, we know what is, we are creating it artificially. Machine learning, we know where the machines are learning. So why comes deep learning? Let me explain these things in a small graphic so that you could relate it better, why it is called deep learning. Now, talking about a human brain, human brain works complicatedly. It's not something which works on a very straight line. There are multiple layers in a brain. Like if you put two people into the same situation, probably the outcome they would figure out or the solution they would figure out will be completely different than what is expected. So same thing applies here, because there are so many layers between the decision point where we reach, that there is so much deep conversation or deep layering happening, and that's why we are calling it a deep learning algorithm. So in this picture, if you see at the bottom, what we are depicting is the neurons. Obviously these are artificial neurons which we have created here using our network, and in that we have multiple nodes. Every node is performing some task, and through these nodes we are able to get output received. So happens here is like we have machine who process data same way like it is done by a human brain, mimicking the neural network of it. It's a multi-layer network, and that's why it is called deep. So if you look here, there are lots and lots of layers. Obviously for pictorial representation I have created only few of them, but there are many layers within it which are making this thing possible. So that's why it is called deep learning, and these are artificial neuron who are allowing us to perform input and then take that output and then come with the prediction outside. So that's what is happening with your deep learning mechanism. Is deep learning clear?
Yes, yes, Ashish. So just wanted to ask you, can you help us an example of how these layers work in action?
Sure, I'll do that. And I'll take a
Yeah.
question from Sandeep. He's asking, are deep learning and neural networks same or one is subset of other? So Sandeep, I would put it like that deep learning uses neural network. So deep learning, to solve the problem, it uses a solution which is made up of neural network like in brain. So it is not a subset, but it is neural network which is making deep learning possible. This is how I would put it. All right. Now coming to your example that how these layers process things, let's go ahead and talk about these specific layers. I'm taking a simple example. You could find it on internet also. Let's say a very simple one. Somebody has handwritten B. Now as a human, I can say that yes, it is B, but for a machine it is not easy to understand what this particular character is. So I'm focusing here right now. So what is this character? Probably my machine is not able to predict it for me. So what I need now, I need to have a solution who could say is it B, and it should be saying that with confidence, not like that. So we take this particular letter, we pixelize it. So we have created different pixels for it. Obviously it would be presented something like this. Like it may not be exact straight line, but we are leveraging pixelation of the image which has been given to it. Now based on this pixelation, what we see now, that my machine could predict that looks like this one particularly here is a specific thing. Like here this is one line, then that could be another line. So this is one line here we have, then this made up of second line here, then maybe a line is like this. So what layer one did, layer one has broken down those pieces into smaller parts. Now these smaller parts are then related, or they are put together, and they are figuring out is what it is representing. So maybe by this small section here, I may think it is representing a D. So machine has said okay, it looks like D. Second section says that hey, it looks like C. If I am just looking at to this particular section, this looks like C. So what is happening now, a machine is trying to predict that what is the edge information, and based on that first layer information, it is trying to predict the complex shapes. And once this is ready, it is able to say okay, looks like these is all the letters are made up of. And now as it will be doing this, it will also start allocating some percentage. Like looks like percentage wise it is 10% A, looks like 85% B, looks like 15% D. So this is probability, and then the output would be whatever is the most probable thing, or whatever is the highest rating which has got. So probably in this case would be B, and through that we are able to predict that how deep learning works. So every layer is performing its own task, and the second layer is taking input from it, and then it keeps moving forward and forward and forward. So that's what a deep learning is. Does it make sense?
Yes, Ashish. So just brings me to another question. Is that safe to say Gen AI is part of deep learning, or are they connected?
That's very correct. So I would say deep learning made Gen AI possible. Deep learning helps you to get these all type of input and process it, because this is what a human brain is doing. So we are generating content, and same way when we are talking about how Gen AI has been made possible, I would say because of deep learning we are able to get to up to a Gen AI. And again I'm saying Gen AI is a byproduct. It is some mechanism. There are models behind the scene, and those models are helping us to get generative AI. So generative AI is the outcome, and what is behind the scene is a deep learning algorithms and models which we have created. This is hopefully giving you a clear picture. So keep this in mind. I will change it a little bit as we move forward. I will try to keep Gen AI a little outside, and I will come back with some more things as we move forward here. But yeah, right now AI is the top, then ML, then deep learning, and then Gen AI comes. Right. Good. Now let's move forward then. Now, I'll give you an example so that you could understand what Gen AI would be able to do. Now, we talked about a chess example. Like, if a machine can play chess based on the rules defined, I would call it is artificial intelligence. If a machine can learn to play chess by analyzing the moves for the other player, then it is a machine learning. Deep learning, machine can learn to play chess by playing against themselves, right? So what it is doing, it is predicting and performing all the, like, he's becoming both the player, and based on that it is able to get a chess game started. And if I'm talking about generative AI, what we are trying to do here, machines that can create a new game based on the rule of chess and prompts given. So machine knows what is a chess game, and now I ask machine that, hey machine, I want you to generate a new game for me, which should be for 4 players, and I want to follow the similar rules which are followed into chess. Obviously, it will not be exact match, but machine can now start generating something new which never existed before based on the input which has been given to it. So that's what generative AI can be referred as, like generating something new which never existed before. Does it make sense?
Yes, Ashish. So just wanted to understand what is this Gen AI all about and what makes it possible, yeah? I mean, how is it able to generate some new content?
Great. Good question. So yeah, generative AI is an outcome which we are seeing, as I always say. But what is happening here? Let's ask this to a chatbot, or let's ask generative AI itself. What is generative AI? So we will be talking about what is generative AI. Now there is a question that what are the different type of learning or training ML? So we discussed it into last batch. So please check. We discussed about different algorithm for machine learning. So coming to question of what is generative AI, so if I ask this question to a generative AI bot itself, probably it would reply that, hey, generative AI is a branch of AI that focuses on creating new data. So focus is generation, a data which never existed. We are trying to create it. Like I am, let's say, an author, and I am writing my book. I am a poet. I am creating a new poetry which did not have, was not existing before. If I am a painter, I am creating a new painting which never existed before. That's what generative AI is. Obviously, I would have learned to write somewhere. I would have first learned alphabet. I would have learned how to create an English sentence. I would have learned how to create different type of sentence structure. And now, based on all the information I got, I am trying to generate something new. That is what we refer as a generative AI. Now, if I go further on that, it is still a subset of machine learning because that's what making it possible. And on top of it, what we are doing, we are trying to create data which is similar, not the same, but that was used to train the model. So whatever was given to the model, output would be inspired by that, but it would be a completely different output which never existed before. That's what we can think of a generative AI. Right now, hopefully everyone is following along, and I'll try to give you an example. So let's say I go to a generative AI model. I'll explain model again in a minute, but what we will do, we will say, hey, I need to have a picture of a golden retriever wearing a glass and a hat in a portrait painting mode. So what happens now? Generative AI knows what is the dog. It knows what is glasses and how people wear it. Probably it would not have a picture of a dog wearing a glass, but it knows a picture of a human who has wore a glass. It knows what is a hat. It knows what is a portrait painting. So all these 4 things combined together, what it is doing now, okay, I know what is a hat, I know what is a golden retriever, I know what is a portrait painting, and I know what is a glass, and let me now try to create a picture for myself. So that is how it is happening here, is like we are creating something, right? Yeah, I agree. I agree, Sharik. I like the dog. I think he knows more about AI than all of us. I agree on that. Dogs are very smart. And if you talk about machine learning, I don't know why, but a lot of machine learning scientists will always talk about pictures of dog, pictures of cat, and they're trying to relate it to the real world. But yeah, this is what generative AI is actually doing, generating content based on the input it already had. Good. So if I now talk about what we are trying to do here, so this is what we already have, this is what we are trying to do, but what had made things possible about generative AI, as you asked, Shashank, what made this thing possible is what we refer as foundational model, or FM for short. So FM is not the FM which we can hear songs on, not that one, but this not frequency modulation. But here we talk about FM, which is called foundational model. So foundational model is making the generative AI possible. So I'll talk about foundation model, but I'll stop. If you have a question here so far, I would be happy to answer any questions which you may have. Shashank, all good? You're following me?
All along. Yep. I was
All
just
along.
looking in the
Good,
chat
nice.
section. Yep. Yep.
No worries, no worries. Thank you. So talking about foundation model, I would say please remember this thing. Foundation model is a versatile AI model trained on extensive, diverse data, adaptable for broad application and tasks. Don't worry, you don't have to remember the definition, but at least try to understand some words from it. First thing, it is a versatile model. Versatile person, versatile substance we have, or like I give some example, like very basic one. Potato is considered as a versatile vegetable. You could mix it with multiple types of vegetable and it will still taste good, right? Same thing here. So it is a foundation model which is versatile. It has been trained on lot of data and it can do broad application. It can perform lots and lots of things. So that is same thing we are trying to go ahead here. This is what we refer as a general purpose model. It was not created to perform one specific task, but it was created to perform a lot of general tasks. Consider it as a generalist rather than being a specialist. Does it make sense?
Yes, Ashish.
Okay. Now, I like
Can I
talking
ask
about
a
movies, so
question?
I'll give you an example from a movie so that you could relate how foundation model is different from other model. Sometimes those are called narrow model because their focus is narrow and they perform one single thing. So let me talk about a movie example here. I'm not sure how many of you have seen movie 300. It is a movie based on the ancient war which happened between Sparta and the other people. What was shown in that movie was this person who is King Leonidas, this guy here. And King Leonidas, it has been shown in the movie that how he was trained, or every Spartan kid was trained like this. Spartans are considered to be very ferocious warriors. And that all was because they were trained like that from the very young age. So in the movie, you would find pictures like this, where Leonidas was sent for extensive training, and he has learned only art of war in the whole life. Obviously, other things also, but his focus was to be a superior warrior in the whole thing. Everything which he was doing was fine tuned to train him to become a warrior. That is what happens is we are talking about a narrow AI which has been created only to solve a specific problem. That is what we refer as a narrow AI. And obviously, what would be opposite of that? That would be what a generalist model is. Consider another analogy here, Shashank. Like probably you all have heard about campus placement, right? What companies do? Companies go to campus colleges, young graduate who have just graduated. They may not know a lot of things, like they want to hire software developer. They may not know the best coding. They want to hire engineer. They may not be the best engineer so far. But what they have done, they have gone through variety of training. They may have studied language. They may have known about history. They may have learned about the mathematics. They may have learned about chemistry and lot of other stuff. So AI system which is designed to perform wide range of tasks, like a graduate coming from college, he or she has been trained on a lot of stuff. And when the time comes, what companies will do? Okay, you have already done the general training, so you can perform various tasks. He may know how to operate Excel. He may know how to write a code. He or she may know how to respond to email. He or she may know how to create a PowerPoint. So these general stuffs are already there, right? Now company may not be able to just hire them for Excel skills or only for their PowerPoint skills. They also have to perform lots of other stuff. So what companies will do now, okay, you already have general training which is a good enough base for me, and now we would go let you go through focused training for a specific role. So we selected 100 people. We would be putting them into our support branch. These 100 will go into software development. These 50 would be into marketing. These 50 will be into data analytics. This 50 will be into machine learning. So what they did, they have taken someone who has a base understanding of it, and then they fine tune those people for specific role which are they going to work on. They give them specific training, maybe for DevOps. They give training for their programming. They give the training for marketing or data analytics or machine learning, and that's how they are able to take a generalist and make them focused on very specific tasks. But that person, as it already has a base, it is able to perform lots of stuff. It is just a matter of training, how we train them, and that's how foundation model actually works. So foundation model is a generalist who can perform lots and lots of stuff. Make sense?
That's a great analogy and definitely helps me understand, like, what is generalist and what is narrow AI, and what if, I want to put a model for general task and for, excel it in a specific task. Thanks, Ashish, for that.
Exactly. So yeah, that's the idea, because we cannot predict every use case which a customer would have. So why don't we create a generalist model who can fine tune, or which can be adjusted? We will talk about adjustment also for a specific use case afterwards. So that we could do. Now, if I try to create a comparison between them, these two models, let's talk about how a traditional model works and how a machine learning model works. See this picture. So in a traditional model, you would have very specific type of training data given to it, very specific, and that specific data will be going through that model and will be generating a very specific task. So maybe I have a model which is only fine tuned for text summarization, another model which is fine tuned only for Q&A, another one for chat. So that was a traditional ML model. But now for foundation model, the base is unlabeled data, because you cannot feed the whole internet data to this particular model, or the work of all the authors in the world. That's not possible. So we feed in this unlabeled data to my foundation model, and now it is able to adapt, this is the right word, adapt, to different tasks which it is given to it, right? So you may not know programming from the very first day on the job, but maybe you have been given training, you have been fine tuned, maybe you shadowed people, maybe you have been given code to analyze, and now you have adopted yourself so that you could write code or solve customers problem. So that is how foundation model take a lot of unlabeled data and then perform and adapt to various type of tasks which we can do. All right. Is everyone okay so far? Are you following along? Great. All right. Now, what else can be there? Let me talk a little bit more on that side. So let's see how the clear picture would look like. So now, as I said that I may change picture a little bit. What I'm doing now here, I am putting foundational models here. And these foundational models can be of different types. Foundation model can be for scientific purpose. Foundation model can be for audio analysis. It could be for vision, like detecting a video or analyzing a video, or it could be text model, which we most commonly use, like Chat GPT. It is a foundational model which is purely fine-tuned for performing all text analysis. So this is what we are trying to achieve from the foundational model. So AI, ML, DL, and FM. And within FM, we have got all the different types of model. And through these models, we are able to create generative AI. So all these models, now some model may be only able to give me text, some may be giving audio, some may be multi-model, which may give multiple output. So that's what generative AI is all about. Does it make sense, Shashank?
Yes,
Yeah,
Ashish, all good. Yep,
good.
gives
Good.
me a good
Okay.
picture. Thanks.
Right. So generative AI is an outcome. Remember the analogy, you have planted a machine learning tree or a AI tree, and the output you are getting now from that is generative AI. And that again explains that why it just happened, like generative AI overtook all the world. The tree was already there, it was growing, it took time to get up to the fruiting level, and now the fruitation has happened, and we are getting the best out of the machine learning, which has been going on for a long, long time. That's how we started. Okay. Now, behind the scene, there is one more terminology which a lot of you may have heard or a lot of you may have understood, is what we call is a large language model. But I'll try to explain some basic concept first, and then we'll go into it. So see this thing here. So machine learning, where you provide simple input and you get simple output from it. Very simple. Simple input, simple output. That's a machine learning thing, very specific. Then we have deep learning. Deep learning says, okay, I have matured enough now, let me solve complex problem for you, and I will be giving you simple output. Think of it like you are giving to a kid a math problem 1 plus 1, and he or she is solving and getting output 2. Simple problem, simple output. Once you graduated or once you have gone into high school, our problems in the maths has gone up, right? We started solving complicated problem, interest calculation, we started doing geometries, we started doing trigonometry, lots of things. So now we got complex input, and that still formatted to a simple output. That is what we call deep learning. And when I am talking about generative AI, we give complex input and we are getting complex output from it. It could be deriving from complex output could be coming from in form of image or text or a sonnet or maybe a haiku or maybe a full paragraph or a resume created for you. It could be n number of things. So that's what is generative AI is helping me with. All right. So this is on a high level what is prediction or what is generative machine learning and deep learning looks like on a high level, right? This is not very technical, but just to give somebody an idea that how you can go ahead and move forward from there. Make sense?
Ashish, yep, it makes sense. For someone who is very new to AI, how would you describe an LLM, a large language model? I'm still, stuck there. Can you help me with it?
Yeah. Yeah, problem with generative AI, Shashank, is there are so many words and so many jargons. You try to understand and get your hand around, and they come up with a new jargon. So LLM is the base for ChatGPT. Let me put it like that. All the models who are smart enough to give you a recipe or give or create itinerary for you for 2 days Spain visit, all is happening because of LLM, large language model. And I call large language model as somebody who says, "Ask me everything. Ask whatever you question you have, put it. Now I'm not promising I will give you the right answer all the time, but I will respond. I'm trained to answer to you, right? You call a support line, you ask some people some question, they may not know answer, but they would respond. Same thing here. So large language model allows you to perform human like conversation. The text you are providing as an input, output will be coming as a text, and through that we are able to perform all the operations. All right. Now I'm not seeing any messages in the chat. So I want to just pause and can everyone give me a +1 if you are still connected to us? I just want to make sure that you are not disconnected and you are still able to listen to us. So just give me a +1 and we'll be continuing afterwards. Yeah, Sharik said, why so quiet? Yeah, it's not a good thing, right? Isn't it? I'm still waiting. Prasad, Sharik, anyone, can you check if everything is okay? Means I'm not sure why. Okay, now I got a response. So looks like there is a delay. Nuruddin, you are saying it from LinkedIn, so I got it from LinkedIn. But let me see if somebody from YouTube responds or not. No, I'm not getting anyone from YouTube. So
Ashish, I
probably
was
there is
connected on.
something wrong.
Yep. Yes, Ashish, I'm connected to YouTube as well, and I see there is a little lag, but people are responding +1 there.
Okay, good.
Yep. Just that it's not getting captured here. That's it.
All right. Yeah, so probably
Yep.
lag is there, and that could be a issue. But everyone, I'm really sorry. Not sure why today is a lag. It doesn't happen most of the time, but right now we are seeing it. Let's see if everyone is still okay and following along. And obviously, recording is there, so you should be able to get it. Uh, There's so many messages. Okay, so
Yes.
I
I
am
see
not
very
able to
positive
see any
messages.
YouTube messages here on my screen. Is anyone else able to see? Sharik, Prasad, Yamira? Nope. Just give me a minute. I'm checking some chat, private chats also. It's working fine. Okay, good. All right. Okay, StreamYard, I am connected. Okay, good. Let's continue then. So if your question remains unanswered, let us know afterwards, and we would be happy to answer it. Shouldn't be a problem at all. But asking question is important thing. You could you unmute me, please? Yes, I'll add you to the stage, Arik.
Yeah, Ashish, can you hear me?
I can hear you now.
Okay, looks like there's some disconnect because I can see some questions on YouTube on my mobile phone and all +1 as well, but somehow that is not reflecting on a StreamYard because I could see the questions are there even
Okay.
before I have asked that. So there are questions, but it's not coming on StreamYard. What I'll do, you
Uh,
continue with that. I'll log on YouTube separately as well, and then we can fix this later on. Not a problem.
Yeah, means if there are any questions, anyone's question, if it remains unanswered, so put them into Discord, LinkedIn groups, and we would be happy to answer it. I'm not sure why technology is not working as expected
Mhm.
today. Yeah, this
Somehow
happens,
YouTube
right?
is not synced properly with StreamYard today. We
Today,
need to check that.
probably.
So not a problem. I'll
Probably I
continue.
made changes on the fly, and that could be one of the reason, right? Prasad, are you seeing the
AI
same
is not
thing?
happening.
Not coming on YouTube.
Ashish, yeah, I can see chat working fine on the YouTube, just
Yeah.
that it is not reflected on StreamYard, so don't worry about it. And I can see, accidental DevOps guy, like that is Sharif, responding to a few of the answers also. So I think it is fine. It's just that we'll check later on why the sync is not working with the
Yeah.
StreamYard
Yeah, so
chat.
we would go through questions afterwards once the stream ends, and we would still be happy to answer questions afterwards. Shouldn't be an issue.
Sure.
Yeah. And Ashish, keep an eye on private chat. If there is something, we will message on private chat
That
in the
makes sense.
StreamYard.
All right.
Right?
Good. Okay.
Cool.
Thank you. So I'll continue with the large language model, and I'll explain what is it and how it works and what happens behind the scenes. So bear with me. I'll show you a slide which has too much text on it. You don't have to remember all the text, Shashank. But yeah, it is just for a reference purpose that what is a large language model. So try to dissect the word. First thing is a language model. So it understands text. It can understand different type of text given to it, and it can generate different type of text as output. So that is a language model. Why it is called large? Because it is asking us to get input from or it has been trained on a large data set, a huge number of data set which is happening. So that what happens into large language model, and that's how we would be able to go ahead and then create a model which would be able to generate answer from. So it is a human like text learning from vast textual data, and that's why we are calling it a larger. And it is one characteristic is that it can respond to unpredictable queries, right? It is meant to respond to you, right? It can say, hey, I don't know. You can say, can you draw me a picture? And it say, no, I am only a language model, I am not able to draw a picture, but I can give you tools information who can draw a picture for you, but it will respond. So it is a model which is flexible, which has ability to respond to queries. And this is not just one, there are multiple type of LLMs being used here, as you could clearly see. So if I'm talking about a generative AI is made up of multiple things like text generation, image, audio, video, and other. And even if I go into text, now for you and me, text could be 1 2 3 4 ABCD, right? Code, your programming code is also a text. So text generation can also happen. Chatbots are there. Code generation can happen. Translation can happen into different language. So that chatbots which you could see are different types. So chat GPT, Titan, Bard, Claude, and then Bing, Pi, Po, these are all commonly used tools we are seeing as output of it. So all these have LLM behind the scene, and because of the LLM they are able to give me the answer I am asking them. Does it make sense, Shashank?
Yes, that definitely helps. So just adds me, it makes me think, what was the logical path Gen AI has taken and how it all started? I mean, what was the journey? Can you help me with that, please?
Good question. And yeah, we need to understand what the basic is and how it started so that we could predict the future and move forward. So let me talk about how it all started. And I'm taking a very high level approach, not going into every single detail, but how it all started behind the scene. It all started with a component which we refer as word embedding. What is word embedding? I'll explain it. Word embedding is a method by which we are able to identify different words and then create a relationship between them. We are able to understand some component and then some relationship between them, and based on that we are able to answer some questions. So that's what word embedding. I'll give you an example so that you would be easy. Again, dog and cat are not going to go away. They will always come whenever we talk about machine learning. So let's say I have this quadrant, I have this 2 axis or a 2D graph which I am plotting, and here all the word in my language which I know as a natural language or different type of languages, I want to put those words here. Let's say for whatever reason dogs ends up into this place. It ends up into the quadrant which is on the left side at the bottom. So dog ends up here from whatever logic I have applied. Now if I am putting the next word in this cat, cat will also be coming somewhere near. Why? Because in natural language we use them into similar sentences. Like I would say I have a pet dog. Similarly, somebody would say, I have a pet cat. Somebody would say, I am taking my dog to a vet. Same thing will happen for the cat also. Somebody would take their cat to a pet, or they would have a cat put a collar. Dog would also have a collar. So in natural language, as we are using these two words in a similar sentence structure, what a model is going to do, model is going to say, looks like there is some relationship between dog and cat, so let me keep it into one quadrant. Now I am for sake of explanation only using two-dimensional thing, but it is a multi-dimensional world which has been created by this model. Now, if I give you a new word car, now car will be obviously not as related to dog and a cat. Maybe dog chase car sometime. That's a different story. But car is not at all or similar to a dog or a cat. But if I have a different word bus, probably this is related, right? Because they both, you can drive a car, you can drive a bus, you would need to see a mechanic if there is a fault, you need to see a mechanic if there is a fault with the bus also. A car can have a flat tire, bus can have a flat tire, dog would never have a flat tire, dog may have a bad stomach, cat can have a bad stomach. So you could see the relationship. So what these models are doing, they learn all the world which is possible in the language and then start putting them into different context, and then start creating some relationship on that. Like, see this thing. So if it is a male female, so men women, king queen, that is a relationship. Then walking, walked, swimming, swam, and then Spain, Madrid, Germany, Berlin. So these words are somehow related somewhere, and that's what the model is keeping in its memory. So this whole thing started by word embedding. Word embedding is a technique that represents objects as a mathematical vector, and this helps machine learning and interpret the real world data. So that is what is happening here into word embedding, right? So consider, instead of just this 4 word, what if I could all the words I know, or I means the whole language world put together into a graph, and that's where everything is easier. So this is how word embedding started. So once people started, or means scientists started word embedding, what they did next, they then moved on from this word embedding to the next phase, which we refer as language model. So now if they can relate things, they can start creating language models out of it. So word embedding gave way to language model, and in this language model we have started using algorithm which is called word to vec or word to vector. We have created word in a vector format which has a direction and which has relationship within it, through which we are able to interpret those things. So word to vec are the family of algorithm by which this text generation is being made possible, and through this we are able to then leverage natural language processing, which summarizes text, question answer can happen, sentiment analysis can happen, speech language can happen. So all of this can happen because of these things. So that's what we mean by how we have come to this particular road. So the road started from embedding, then we created some language model, then we created word to vec, and then we have natural language processing, and that is how your natural language is being processed by large language models. I'll give you one more example, Shashank, so you could relate to this thing, how it works out. Now, let me give you an example. So let's say we are predicting the next word. What I'm seeing here is a sentence. Everything has been blocked, all yellow I can't see, but I'm seeing the last word here which says lazy and dash. And you ask me, can you predict what would be the next word? Now, it could be n number of things. I would say most probable words which would come is lazy person, right? We call people, hey, that is a lazy person. We don't call that is my lazy computer. We don't say that most of the time, right? So we lazy probably relates to person. So what my model is doing now, model is predicting that I have seen a lot of time lazy being referenced for a person. So probably it is a lazy person which is there. But now what I do, I give my model more context. I say, okay, model, you are able to predict person. Let me give you some more context. Now see this thing. What I did, I gave my model, fox jumps over the lazy underscore. Now, probably person is not the right word here, right? A fox probably won't be jumping over a lazy person. In some fictional novel, it may happen, but in real life, that is a very uncommon thing to happen. So model would say, person may not be the best thing to come here. It should be something else coming up. What it could be? See, fox exists into a space where it would be existing with different animals, right? So fox and rabbit, they probably would be seen together. So fox may be chasing rabbits, rabbit will be running when they see fox, or they exist in the same space. So model would say probably looks like rabbit should be the right word to come here. So fox jumps over the lazy rabbit. Still makes sense to me, right? But is it right? Probably not. We will see, because what is happening, I still do not see first 3 letters in my whole sentence, and that's why I'm not able to predict everything. So how it started, the behind the scene mechanism for this thing which we are discussing is something called transformers. Not the movie Transformers, but transformer here is a article. It is a white paper which is published called Attention is All You Need. It happened in 2017, and that was the monumental moment for generative AI. It is a smaller, it is not a huge white paper, but it is complicated. And this Attention is All You Need model or paper talks about this, which we refer as a transformer model. So idea of transformer model is that take the text, put it into model, generate output, take the output again, put it back into the text, and keep on generating output. So if you see these arrows, so we are doing feed forward. So we got information, feed it forward. We got the information, feed forward. And that's how my output is coming up. So we provide input to transformer. It goes through different phases and it keeps on making changes and moving forward. And that's how we come to output. So behind the scene mechanism is all happening through transformer model. Now, what I can do now, let's say now I give to my model more information. Now I have given this model this information like the quick brown fox jumps over the lazy and underscore. Probably you know this thing. If you use Windows in Windows font, this is a statement which is most time return, and this contains all the alphabets of English language. This is what we refer as a panagram. So machine would have learned somewhere panagram, and now it would be 100% sure, or at least 99.99% sure, that now we are getting here a dog as a sentence. So it first thought it can be a lazy person, then it thought it could be a lazy rabbit, but then when the whole context was visible, it is able to say no, it is probable that it will be a lazy dog, which is the word which is coming up. And that is how it feeds on small input, keeps on enhancing it, and generate the output for me. That's how the road to generative AI has come. So this is how we have started generating all the text-based data. Makes sense?
Yes, and that really helps me to connect the dots from the journey we started till now, all the words that I've heard so far. Thanks, Ashish.
Exactly. So yeah, that is how the transformer model works behind the scenes. So what we do in transformer model, we take inputs. Let's say same example. Now we are going a little differently. A puppy is to dog as a kitten is to. We do not know the word. What we want this information to be processed by LLM. So LLM goes through these 4 steps. It goes through tokenization and encoding. It will then perform word embedding and it will decode and then generate the output. I will be a little quick because of the time, but let me explain what happens. Now, tokenization is a basic fundamental thing which happens when you put an input, and tokens are important based on the cost and the performance. Tokens are important. So tokenization is fundamental step in natural language processing. Tokenization is to represent text in a manner that meaningful to machine. See, I know words easily. You remember words easily. You remember person's name easily. But machine do not remember names. Machine need numbers. So any input which I am giving in, I have to ensure that machine can understand it. And a machine is learning is still like a kid. So if I am teaching a kid, I won't be giving them a passage from my book. This book is Cloud Career Journeys. I won't be giving a passage from this book. If I'm teaching a kid, I have to start with the fundamentals, which is A or B or C. So what happens now? Let's say I go to my machine and input the word listen. What a machine is doing now, machine is converting it into tokens. So tokenization is the process of converting input text into smaller unit. So L, this is ASCII code for L, I ASCII code, S, T, E, N. So what machine did, machine is able to create a tokenized value for listen, and let's say the total value comes up XYZ and it stored it. But the same characters are used for the word silent also. So if machine is just making a prediction based on the numbers, it would be confused that are these numbers representing listen or are these numbers representing silent. So in some model, instead of breaking down a single character, what we do that we break down the whole sentences. Let me show an example of that. So what we could have done something like this tokenization. So I love my dog, and then I love my cat. I have given first 001 number, 2, 3, and 4. And now when I would write I love my cat, now I could clearly see that first three words are not changing, the last is changing. So now machine knows that looks like there is a similarity between dog and cat because they are being used into the same context or in the similar format we have used it. So now machine is able to learn that dog and cat exist into the same space when I'm building it. So now what machine would do? Machine would take my sentence, convert it into the tokens which we see here, and then it will encode it, and afterward it would plot all the word from my sentence. So when my word is plotted like a cat, there would be kitten, dog, there is a puppy, young, there is a canine, there is a old. So as you could see, cat and kitten are coming into the same vector, dog and puppy are coming into the same vector. So probably the next probable word here is going to be the puppy. So same thing here, a puppy is to dog, is kitten to a cat. So it is trying to figure out, should it be cat, should it be bird, should it be bear, should it be human? And these probably are the probabilities of how many times we have found out the similar sentences. So what is going to happen now, we would say looks like cat is the most probable answer. So we decoded whatever output we got, and then we generate the output and give it back to the system. So this is what happens, a puppy is to dog as a kitten is to cat. That's how the complete process works. Now I generated one sentence. What if I generate the same sentence and give it back to the transformer model? Second sentence generated, give it back. Third sentence, I can say, okay, I am giving you a para, generate the next para. I am giving you one page, generate the next page for me. So that is exactly same thing happening all and all time, that tokenization happens when we send input, word embedding is then checked, decoding happens, and then output is generated. So this is how behind the scene LLM models actually work, right? So I'll stop here now, and I'll wait. If you have any questions, any doubts, I would be happy to answer any questions related to it. All good, Shashank?
All good. Was just trying to wrap my head around tokenization,
Yeah,
embedding,
there is so much
decoding
information.
outputs.
So
Yep,
exactly, so
all
that's
first
what the beauty
steps.
of
But yeah,
YouTube is. You could go ahead and record it is already there, so you could revisit it. So I don't
yeah,
expect that you will become master in one day. Nobody can become. Same thing, we also tried and learned multiple times, so feel free to watch it again. But I have given you the gist of how LLM works, how to utilize these models. We would be discussing them into the next chapter. So I would stop here from the technical perspective, and really sorry for all the mishap of question not being seen onto to us, but we would answer as many questions afterward as we can. All right. Can we label this term in a simpler words? There is a question from Emmerich. See, Emmerich, you could call whatever you want as. I would put it like, if I had to put it here, I would say that tokenization is, see, this is my wording. Obviously, it is not the official answers from the machine learning expert. I would say I would be numbering the word, right? And then, so I am first doing is numbering the word which I got as an input. Then what I was doing, I am trying to find a relationship between them, and then I am trying to perform a probability of whatever I got, and then I'm generating the output for you. So this is what is happening behind the scene. All the numbers has been generated from the token or from the sentence you have given. They have been put together into a relation format, and then probability was checked that what could be the next generated word, and then the generation of the word happens. So this is what could be the complete process from the machine learning perspective, which is happening whenever you are saying anything to ChatGPT. Okay, good. So we completed around 50 minutes of discussion, and I think it is hopefully you got a good understanding, Shashank, and we will be seeing more complex things as we move forward. But feedback is important, everyone. So anything which you have feel that we can improve upon, anything which we can make do to make your learning better, just let us know, and we would be happy to get together and then finish those things.